Horton Ho229 nach die Jäger. Its role was a fighter bomber. Its manufacturer was Gotha Wagenfabrik. Its designer was the Horton brothers. Its first flight was 1st March 1944 as a glider. Its primary user was the Luftwaffe. 3 of them were built, and it was developed into the Gotha Go P60. The Horton Ho9 RLM designation Ho229, or Gotha Go 229, for extensive redesign work done by Gotha to prepare the aircraft for mass production, was a German prototype fighter bomber initially designed by Reimer and Walter Horton to be built by Gotha Wagenfabrik. Developed at a late stage in the Second World War, it was the first flying wing to be powered by jet engines. It had been designed in response to a call by Hermann Göring, the head of the Luftwaffe. In 1943, the light bomber designs capable of meeting the 3 × 1,000 requirement, namely, to carry 1,000 kilograms, 2,200 pounds, of bombs a distance of 1,000 kilometers, or 620 miles, with a speed of 1,000 kilometers per hour, or 620 miles per hour. Only jet propulsion was capable of achieving the required speed, but such engines were relatively primitive and extremely fuel-hungry, necessitating considerable effort across the rest of the design in order to satisfy the range requirement as well. The flying wing configuration was favored by the Horton brothers due to its high aerodynamic efficiency, as had been demonstrated by the Horton Ho 4 glider. In order to minimize drag, the Horton Ho229 was not fitted with any extraneous flight control surfaces, and its ceiling was 15,000 meters, or 49,000 feet. The 229 was the only design that even came close to the requirements set out, and the Horton brothers quickly received an initial order for 3 prototypes after the project garnered Göring's approval. Due to the Horton brothers lacking appropriate production facilities, the Ho229's manufacturing was contracted out to Gotha Wagenfabrik. However, the company allegedly undermined the project and sought to have the Air Ministry officials favor its own flying wing designs instead. On 1st March 1944, the first prototype, H9V1, a unpowered glider, performed its maiden flight. It was followed by the H9V2 powered by Junkers Umo 004 turbojet engines in 1944 December. However, on 18th February 1945, the V2 was destroyed in a fatal crash, killing its test pilot. Despite as many 100 production aircraft being ordered, none were ever completed. The near-complete H9V3 prototype was amongst the items captured by the American military and transferred back to the United States under Operation Paperclip. It was evaluated by both British and American researchers before entering long-term storage, and it is currently present on static display at the Smithsonian National Air and Space Museum. Design and development. During the early 1930s, the Horton brothers had become interested in flying wing configurations as a method of improving the performance on their gliders. At that time, the German government had been actively funding glider clubs across the country as a response to the production of military and even motorized aircraft being forbidden by the Treaty of Versailles after the First War. The flying wing layout removed the need for a tail and associated control surfaces and theoretically offered the lowest possible weight using wings that were relatively short and sturdy, and without the added drag of the fuselage. Their first aircraft of such a configuration was the Horton Ho 4. In 1943, Göring issued the request referenced earlier for the 3 × 1,000 requirements. Conventional German bombers were capable of reaching Allied targets across Great Britain, but were suffering devastating losses from Allied fighters in the process. At the time, there was no conventional means for aircraft designers to meet these goals. The new Junkers Umo 004 Bravo turbojets could provide the required speed, but had excessive fuel consumption. However, the brothers concluded that the low-drag flying wing design could meet all of their goals. By reducing the drag, cruise power could be lowered to the point where the range requirement could be met. They put their private project, the H9, as the basis for the bomber. The RLM quickly approved the Horton proposal, but ordered the addition of two 30mm cannons, as they felt the aircraft would also be useful as a fighter due to its estimated top speed being significantly higher than any other Allied aircraft at the time. German officials assigned the designation HO229 to the aircraft. Goering was reportedly impressed with the design and personally intervened to ensure that 3 prototypes were ordered at a cost of 500,000 Reichsmarks each. At one point, the Air Ministry issued an order for 100 production aircraft, although this was subsequently curtailed to only 20. Observing the difficulties present in the 229's design and development, the chair of the Aeronautics Department at the National Air and Space Museum speculated that an important motivating factor of the project for the Horton brothers was to prevent them and their workers from being assigned to more dangerous roles by the German military. Looking beyond the 229, the Horton brothers produced numerous flying wing designs, such as the Horton Ho229 fighter trainer and the Horton Ho229 Amerika bomber. The H-9 was of mixed construction. While the center pod was made from welded steel tubing, the wing spars were composed of pine. The wings were made up of a pair of thin plywood panels that were glued together with a charcoal and sawdust mixture. The exterior was covered by a fireproof paint. The wing had a single main spar penetrated by the jet engine outlets and a secondary spar used for attaching them. It was designed with a 7G load factor and a 1.8x safety rating. Therefore, the aircraft had a 12.6G ultimate load rating. The wing's chord thickness ratio ranged from 15% at the root to 8% at the wingtips. There was relatively little available interior space, making the addition of new equipment or more crew members either difficult or nearly impossible. The aircraft was fitted with a retractable tricycle landing gear with a nose gear on the first 2 prototypes sourced from the HE-177's tailwheel system, and the third prototype using an HE-177 Alpha main gear wheel rim and its tire on a custom-designed nose gear strutwork and wheel fork. A drogue parachute slows the aircraft upon landing. The pilot sat on a primitive ejection seat, and a special pressure suit was developed by Drege. While the aircraft had originally been designed to be powered by the BMW 003 turbojet engine, this engine was not quite ready at the time, and thus the Junkers UMO 004 was substituted. Flight control was achieved via a combination of elevons and spoilers. This control system included both long-span, inboard, and short-span, outboard spoilers, with the smaller outboard spoilers activated first. It was reported to provide a smoother and more graceful control of yaw than would have been by a single spoiler system. Operational history. Testing and evaluation. On March 1, 1944, the first prototype, V1, an unpowered glider with fixed tricycle landing gear, performed its maiden flight. Flight results were very favorable, but there was an accident when the pilot attempted to land without first retracting an instrument-carrying pole extending from the aircraft. The V1 was followed in December of that year by the Junkers UMO 004 powered second prototype H9 V2. The BMW 003 engine had been preferred but was still not available in sufficient quantity. Goering believed in the design and ordered a production series of 40 aircraft, RLM designation HO229, even though it had not yet taken to air under jet power. On 2nd February 1945, the first flight of the H9 V2 was conducted. The Horton brothers were unable to witness this flight as they were occupied with producing the design for a new turbojet-powered strategic bomber in response to the Amerika bomber competition. All of the subsequent test flights and development were conducted by Gotha Wagenfabrik. The test pilot was Lieutenant Erwin Ziller. 2 further test flights were performed on 2nd February 1945 and again on 18th February 1945. Disaster struck during the third test flight. Zilla took off without any problems to perform a series of test flights. After about 45 minutes at an altitude of 800 meters, one of the Jumo 004 turbojet engines developed a problem, caught fire, and stopped. Zilla was seen to put the aircraft into a dive and pull up several times in an attempt to restart the engine and save the precious prototype. Zilla undertook a series of 4 complete turns at 20-degree angle of bank. He did not use his radio or eject from the aircraft. He may already have been unconscious as a result of the burning engine. The aircraft crashed just outside of the boundary of the airfield. He was thrown from the aircraft on impact and died from his injuries 2 weeks later. The prototype aircraft was completely destroyed. Despite this setback, the project continued with sustained energy. On 12 March 1945, nearly a week after the U.S. Army had launched Operation Lumberjack to cross the Rhine River, the 229 was included in the Jäger-Notprogramm, or the Emergency Fighter Program, for accelerated production of inexpensive Wunderwaffe, or wonder weapons. In the same month, work commenced on a third prototype, the 229 V3. This was larger than the previous prototypes, the shape being modified in various areas, and it was meant to be a template for the pre-production series 229 Alpha-0 day fighters, of which 20 machines had been ordered. The V3 was meant to be powered by 2 Jumo 004C engines with 10% greater thrust each than earlier Jumo 004 Bravo production engines used for the ME-262 Alpha and Dorado 234B, and could carry 2 Mark 108 30mm cannons in the wing roots. Work had also been started on the 2-seat HO229 V4 and 229 V5 Nachtjäger fighter prototypes. The Horton 229 V6 armament test prototype and the V7 2-seat trainer. In April 1945, Patton's Third Army found 4 steel and wood Horton prototypes, a Horton glider, and the V3, which was still going under final assembly. Of 3 airframes, the V3 was nearest to completion and was shipped to the United States for evaluation. Along the way, the 229 spent a brief time at RAE Farnborough in the UK, during which it was evaluated as to whether British jet engines could be installed, but the mountings were found to be incompatible with early British turbojets, which used the larger diameter centrifugal compressors as opposed to the slimmer axial flow turbojets the Germans had developed. The Americans were just starting to create their own axial compressor turbojets before the conflict's end, such as the Westinghouse J30, with thrust level only approaching the BMW 003 Alpha's full output. It is uncertain if the aircraft's original Junkers-supplied engines were ever ran, although the American evaluation team at one point had the intention of flying it. Claimed stealth technology. Radar absorbent material. In 1983, Reimar Horton stated that he intended to mix charcoal dust in with the wood glue to absorb electromagnetic waves, or radar, which he believed could shield the aircraft from detection by the British early warning ground-based radar that operated at 20 to 30 megahertz or 10 to 15 meters wavelength, basically the top end of the high-frequency band, or known as chain home. This charcoal glue treatment was planned for the never-made production model. However, it remained unclear if the V3 prototype had benefited from a preliminary iteration of this technology. In 2008, a team of engineers from Northrop Grumman undertook electromagnetic tests on the V3's multi-layer wooden center section nose cones. They tested over frequency ranges of 12 to 117 terahertz, with the wavelengths of the order of 10 microns. The cones are 19 millimeters or 0.75 inches thick and made from thin sheets of veneer. The team observed that the 229 leading edge has the same characteristics as the plywood of the control sample, except that the frequency did not exactly match and have a shorter bandwidth. The team, who had assumed the presence of black carbon from visual inspection, went on to conclude that the similarity of the two tests indicates that the design using the carbon black type material produced a poor absorber. The Smithsonian Institution has performed a technical study of the materials used on the prototype and determined there is no evidence of carbon black or charcoal, thus invalidating the proposed presence of carbon black to explain the slightly different absorbent property of the prototype wood compared to the control sample of the plywood used in the Northrop Grumman testing. Radar cross-section and shape. A jet-powered flying wing design such as the 229 has a smaller radar cross-section than a conventional contemporary twin-engine aircraft because the wings blended into the fuselage and there are no large propeller discs or vertical and horizontal tail surfaces to provide a typical identifiable radar signature. Variants. The V1 was the first prototype, an unpowered glider, one built and flown. The V2 was the first powered prototype, one built and flown with twin Junkers Jumo 004 Bravo engines. The Gotha development. The V3. Revised air intakes, engines moved forward to correct longitudinal imbalance. Its nearly completed airframe was captured in production with two Junkers Jumo 004 Bravo jet engines installed in the airframe. V4. Planned two-seat all-weather fighter, in construction, but not much more than the center section's tubular framework completed. V5. Planned two-seat all-weather fighter, in construction, but not much more than the center section's tubular framework completed. The V6. Projected, definitive single-seat fighter version with different cannon, one captured in production by U.S. troops. Horton developments. The 9B, or also designated as V6 and V7 by the Hortons. It was a projected two-seat trainer or night fighter, and it was not built. The AO was a projected expedited production version based on the 229 V6, not built. V2 specifications. Crew was 1. Its length was 24 feet 3 inches. The 229A was 24.5 feet. Its wingspan was 55.1 inches, or on the 229A, 55 feet. Its height was 3 feet 7 inches at cockpit height. The 229A was 9 feet 0.3 inches overall height. The wing area was 568 square feet. On the 229A, this was 540 square feet. Its aspect ratio was 7 to 8. Its airfoil was 13% thickness. Its empty weight was 10,679 pounds, and the 229A was 10,100 pounds. Its max takeoff weight was 15,159 pounds, and the 229A was 17,900 pounds. Its fuel capacity was 3,700 pounds. Both of the Junkers Jumo 004 Bravo turbojet engines produced 8.83 kilonewtons of thrust each. Its maximum speed was 600 miles an hour. The 229 was 590 miles an hour at sea level, or 607 miles an hour at 39,000 feet. Its cruise speed was 560 miles an hour, and the never exceed speed was 620 miles an hour. Its takeoff speed was 93 miles an hour, landing speed of 81 miles an hour. Its range was 1,000 nautical miles. Its rate of climb was 4,300 feet a minute. Its wing loading was 27 pounds per square foot, and the thrust weight was 0.382. It carried two 30mm 1.81 inches Mark 108 cannon. Conclusions. When World War II ended, Reimar Horton emigrated to Argentina after failed negotiations with the UK and China, where he continued designing and building gliders, one experimental supersonic delta-wing aircraft, and one twin-engine flying wing transport, which he called the Naranjero, for its intended use of carrying oranges for export. It was unsuccessful commercially. Voght remained in Germany after the war and became an officer in the post-war German Air Force. Reimar died on his ranch in Argentina in 1994, and Voght died in Germany in 1998. On July 10, 2013, 69 years after the first Horton Ho229 was test flown, the U.S. Navy successfully conducted takeoff, landings, and touch-and-goes from the aircraft carrier USS George H.W. Bush with a new stealth jet called the X-47 Bravo UCAS built by Northrop Grumman. What is so different about this plane is the fact that it is a drone.
Wir fühlen den Osten und Höhen, des Adlers verwegendes Glück.